Today we're gonna try and solve Heron's formula. Heron's formula states that the area of a triangle with sidelines A, B, and C and semiperimeter S is equal to the square roots of S times S minus A times S minus B times S minus C. So we're trying to prove that. First of all, here's our triangle. Let's say it has height h, and we're gonna call that B1 and the other one B2. And we're gonna start by writing down a few things that we already know. Most obviously, B1 plus B2 equals B. H squared equals A squared minus B1 squared. H squared also equals C squared minus B2 squared. So we're gonna try subtracting equations 2 and 3. I think we can factorize that. So we have B1 squared minus B2 squared, which can be simplified to B1 minus B2 times B1 plus B2. I'll leave the right-hand side alone because I noticed that B1 plus B2 equals B. Dividing by B, we get B1 minus B2 equals A squared minus C squared over B. We're going to try subtracting equation 1 from that. It says that B1 plus B2 equals B. For a common denominator, I'm going to divide B by B and multiply B again. Adding these equations, we get 2b1 equals a squared plus b squared minus c squared over b. Since h equals a squared minus b1 squared, we can say that the area is equal to
1 over 2b times root a squared times 4b squared over 4b squared minus a squared plus b squared minus c squared over 2b squared.
This can be simplified to 1 over 2b times the square root of 1 over 4b squared times 2ab squared minus a squared plus b squared minus c squared squared. We'll take the 1 over 2b inside the root, meaning that the b squared and the over b squared will cancel each other out, and over 4 times over 4 equals over 16, so our result would be root 1 over 16 times all that. I'll rewrite that on a new page. We see some stuff that we can factorize like this. So we can simplify our equation further. We can distribute 1 over 16 to each of our little parentheses, giving each of them a denominator of 2. The last one we notice is equal to the semiperimeter. Let's call it S just because Heron did. So we can express the whole thing as S times something. So you just need to find out what goes between those parentheses. So we'll take one of those fractions down. This one's numerator is A plus B minus C, which is equal to A plus B plus C minus C, which can be further simplified to S minus C. Similarly, all of these fractions can be simplified to S minus A, B, or C, from which we can get Heron's formula. That's it for today, thanks for watching.